Welcome to physics. This lesson is sponsored by brilliant.org. Today I'm going to show you another example of a vector addition. So let's get started. Let me write down the problem. 4 meter to east and 2 meter to the north. 2 meter to west and 5 meter to south. 5 meter to west and 5 meter to north. And finally on Thursday, 1 meter to east and 5 meter to south. 4 meter to the east means positive 4 and 2 meter to the north means positive 2. What does that mean? X comma y is equal to 4 comma 2. 2 meter to the west means negative 2. So x comma y negative 2. 5 meter to the south negative 5. X comma y. 5 meter to the west, let's see, negative 5, and 5 meter to the north, positive 5. 1 meter to the east, 1, and 5 meter to the south, negative 5. Alright, so I'm going to now draw the coordinate plane and we will take it from there. Okay, this vector over here is purple vector over here, which is 4 meter to the east. So 4 meter to the east. Okay, I'm going to take the tail of this vector and put it on the head. Alright, and this is 2 meter to the north. 2 meter to the north. Now head and tail method. From tail to head. So I'm going to add these two vectors. Alright. So this is the red one. I'm adding these two vectors. So I'm done with vector 1. Now I'm going to do vector 2. Vector 2, I have 2 meter to the west. 2 meter to the west. 2 meter to the west is the vector this direction. And 5 meter to the south is the vector this direction. So I'm going to first draw the x component, which is 2 meter to the west. So 2 meter to the west. So this is the 2 meter to the west. Now I'm going to find the head and I'm going to put the tail. This should be the green one. I'm going to put the tail on the top of the head. And I'm going to move 5 meter to the south. So right here. Okay. So this is the resultant. Alright, from tail to head. This is the resultant. Now, I'm going to do the vector number 3. 5 meter to the west. So 5 meter to the west would be like that. And 5 meter to the north. 5 meter to the north would be this. Alright, so now I'm going to first draw the x one, 5 meter to the west. So this is 5. So 5 meter to the west. Okay. Now 5 meter to the north. So I'm going to find the tail. I'll put the tail on the top of the head. And I'm going to draw 5 meter to the north. So right here. Okay. So I'm going to connect the tail to head. And then finally I'm going to draw the resultant. Okay. Now I'm going to put them together. So let's put them together. What I'm going to do, I'm going to put the this displacement and this displacement and this displacement and this displacement. I'm going to put all three displacement on top of each other to find the final displacement from the origin. So we're gonna go to the head of this one and draw this one. Okay, so we are on the head of this one, and then we start counting. -2, 1, 2, and -5. 1, 2, 3, 4, 5. This is the next one. Alright, we're done with this one. Now you're going to draw this one. This one is -5, 5. So -5 is the x direction. So 1, 1, 2, 3, 4, 5. And the positive 5 at the y direction. 1, 2, 3, 4, 5. Alright, we're done with this one. Now you're going to do this one. 1, -5. Now we're going to go to the 1 to the x direction. So 1 and then -5. 1, 2, 3, 4, 5. -5. We can use the different color. Alright. Now we're gonna finally draw the displacement. Displacement is the shortest distance between. Displacement is the shortest distance between the initial and the final. So this is the displacement. So let's see, what is this one? So 1, 2. So this one is 1, 2. So -2. So x, y. So x is 1 and 2, -2, 1, 2, and 3, -3. Alright, so we're gonna have to find the displacement. So the resultant is c squared is equal to a squared plus b squared. So c squared is a squared is -2 squared plus b squared is -3 squared. So c squared is 4 plus 9. So c squared is square root of 13. Bari is square root of 13 meter from the origin. This video was sponsored by Brilliant.